Hi everyone. So today we will be solving two sum problem. Okay. So first we will be going through the description of this problem. Then we will be solving this problem using brute force approach. Then we will see the optimal solution for this problem. Let's see the problem. Okay. So we have given an integer of array nums and an integer target. Return indices of the two numbers such that they have added to target. Okay. You may assume that each input would exactly have one solution and you may not be using the same value twice. So suppose this is our array 2, 7, 11, 15, and our target is 9. So we need to find two numbers whose sum is equals to 9. Okay, I hope this is fine. So when we add 2 and 7, we will get target as 9. So what will be the indices of these two numbers? So currently we have the indices as 0 and 1. Okay, when we sum up this 0th index number with 1th index number, we will get this 9. Okay, I hope this is fine. And we need to return these indices in an array. Okay, I hope this point is clear with you guys. Let's see the constraint for this question. So constraint is 10 to power 4 is the array length of an array. The num can be negative, target can be negative, and only one valid answer exists, which means there cannot be repeated answer, and there will be only sum of two elements we need to find, and exactly one solution is there. Okay, so these are the follow-ups will be like you can come up with the algorithm is less than O of n square. So we will see three approach with different things. Okay, so I hope question is clear with you guys. Let's see with an example and then we will be coming up with approaches as well. Okay, I will solve with this example. Okay, 2, 7, 11, 15, and target is 9. Let's say 2, 7, 11, 15, and the target is 9. So when our target is 9, okay, so first what we will do, we will be 2 plus 7, we will get 9. Okay, and 2 plus 11, we will get 13. 2 plus 50, we will get 2 plus 15, we will get 17. Similarly 7 plus 11, we will get 18. 7 plus 50, we will get 22. 11 plus 15, we will get 26. These are the combination we are getting, but we need to find those indices whose sum is greater than, like sum is equals to 9. Okay, this is our target value. Okay, so these are the two indices like 0 and 1. So we have to find those indices whose sum is equals to target. So 2 and 2 and 7 are the indices, or are the number whose sum is equals to target. So we need to return the indices of these two numbers. Okay, I hope the question is clear. Let's see the brute force approach for this question. Okay, yeah. So I hope this thing code is clear to you guys. I will explain this code. Okay, so because we need to return the indices of two numbers, so first what I will do, I will make an array. So here I made an array. This is my array of two number. In this I will store the value and I will return it. Yeah. So basically what I will do, I will run a loop from 0 to n. I will start from here and j will start from here. Okay. You will see this thing in code as well. Okay. Let's see here. So I will run a loop. First I will take a array which will store the indices, and then I will run a loop from 0 to n. This is for I, and 1 to n. This is for j. And then I will check like these two values are equals to the sum of these two values are equals to target. Okay, and why this condition? This condition because in question it is mentioned like you may not use the same value element twice, like we cannot use the same value twice. So we have to check like that I and j doesn't match. If they are matching, then we are using the same value twice. So because of that we are using this condition. Okay, so this is the brute force approach. Okay, then what I will do, I will store if these two both, if these both the conditions are true, like we are getting the target value and both elements are not matching, then we are storing those values in that array. Okay, this is our result array, and we are checking a flag. why we are checking this flag? So we are checking this flag because once we are getting this value, because there are only one solution, and once we are getting that value, we will break it. Okay, so we make this flag, we make it 1, and then if that flag is 1, we will come out of this loop, and then we will return our array. So if we are not doing this, what will happen? It will run O of n. Okay, eventually it will run O of n, but somewhere in between we find that value, we find the target value, we will come out of this loop. Okay, that's why we are using this. Okay, I hope this point is fine. So this is our brute force approach, and this is how we can do this question by brute force approach. What will be the next approach? So next approach, what we can do, we can use two pointer approach. I will explain how we can use two pointer approach in this question. So what we will do in two pointer approach. So because as you can see in this question 2, 7, 11, 15. So this array is sorted, but there is nowhere it is mentioned like our array will be sorted. Okay. Suppose if our array is not sorted like this 3 to 4. Okay. So in this case 3 to 4 can be used two pointer. Think. Just think, can we use two pointer approach in this? No, we cannot use two pointer approaches. Like because for two pointer we need to use comparisons. We need to use comparison. We have some comparison, then only we can use two pointer approach. Okay, then we can find those target values. Okay, so suppose if I run this, run one pointer from start, one pointer from end, and we will check the target value. So for in this case, what will be the target? Our target is 6. So target is equals to 6. Okay, so how we will run? Okay, I am right now, I'm not sorting it. Okay, I'm just giving you an overview why we are not, why we are not able to solve this question without sorting it. Okay, so suppose I will start from 0 and J will start from n minus 1. Okay, then we will check, like we will sum these two values, 4 3 7. So it will 7, it is not equals to target. Again we will increase I and J, but on what basis we will increase I and J? Because the sum of these two values are greater than. Okay, sum of these two values are greater than target value. So what we can do, we can reduce the greater value, then we will reach the target value. Okay, I hope this point is clear. If I am reducing this J to here, okay, in that 2, okay, then what we will get, we will get 5. Is it equals to target value? No, it is not equals to the target value. Then in that case what we will do, we will increase this I. Then our I and J both points to 2. Is it equals to the target value? No, it is not equals to the target value. Then what we will do, we will again increase it. No, that's a wrong way to do it. Like we will be in the loop. Okay, so remove that loop. What the next thing we can do, what we can do, we can sort this array. Okay, we can sort this array, and then we can use two pointer approach. Okay, we can do that. So suppose this is sorted array, and now you can easily track this. Our target is 6. I will be 0, J will be 4, and we will get 6. And we can break it and come out of this. Or suppose this is another array, something like that, we can easily do that. Okay, if it is greater value, like our sum will be greater than target value, we can reduce the smaller value. We will reduce the count of, like we will reduce the value of J. Okay, suppose like I will write it, if sum will be greater than target. Okay, if it is the case, then they will reduce. It reduce. If sum is less than target, we can increase I will increase, I will increase. So this is the another approach we can use. Now talking about the complexity of these two approaches. So what will be the complexity of these two approach? The first approach, we are using O of n square. Okay, I hope you guys able to find, like I hope you guys able to track the complexity. So complexity of this problem will be O, or solution will be O of n square. Okay, why O of n square? We are running two loop. In worst case it will run whole n into n minus, this loop will run n times, and this will run next a j1 will run n minus 1 time. Okay, so if it is running n minus 1 time, so it will be n of n minus 1. Okay, which will be O of n square. And if we are talking about this approach, so in this approach, what we have, we are using two pointers approach. So as we are using two pointer approach, already we need to sort the array. So sorting will take O of n log n. Okay, n log n. Okay, so it will be a O of on n log n approach. Okay, so this is the complexity of this approach. So but in the question it is mentioned like we need to solve this by using lesser complexity than O of n square. So this is right solution according to it. But can we do it better? Yeah, we can do it better. So for doing this in a better or optimal approach, what we need to do? We need to use hash map. Okay. Now see how we will use hash map in this. Okay. So this is our hash map solution. Okay. So what we are doing? We are making similar things we are doing here. Like we are okay. So we are using an array to store our result. Then we made a hash map. Okay, so after making an hash map of integer and integer, our key and value pair will be integer. Okay, so now what we will do, we will run a loop from 0 to length of an array, and we will check. Suppose this is our array 2 7 11 15 and target is 9. Okay, I will solve by this example, and we will submit this code as well. 2 7 11 15 and target is 9. Okay. So how we will do this? How we will use this hash map efficiently? So first what we will do, we will be running a loop. Our loop will run from 0 to n. Okay. Where n is 4 in our case. Okay. So n is 4 in our case. First we will check like if map contains this value. Suppose what we need to check. What let's say if we put 2 in map randomly, we put 2 in map. Okay, then what will be the sum we need to find in that array? Okay, what is the remaining part we need to find in that array? So it will be 9 minus 2. Okay, I hope this is clear. Suppose if we are talking about this thing, 2 plus 7 equals to 9. Okay, so this is our target value, this is our first value, this is our second value. So if we need to find the second value, what we can do? Second value, if we need to find the second value, we can write it like this: the second value equals to 9 minus first value, or we can write it like this: target minus first value. I hope this is fine. Target minus first value, that's what we are checking. We are checking in the map either we are containing the target minus value or not. Okay, so this condition will check like if we are containing the target minus value in that map, then we are getting that value and we are putting the index. So we are making this hash map and we are putting the index as well. Okay, yeah, so our map will contains the value and its index. Okay, our map will contain this. So for the first element, what how map will look like? Okay, I will show you, just give me a minute how our map will look like. So first of all, our map will look like something like this: 2 comma 0. This will be our key and this will be the value. Yeah. Okay, next what we will check, we will check for 7, and we will check for 7. Then we what we will do, we will come in this condition, we will check is map dot contains key target minus nums of I, where I will be 1. Okay, so target is 9, 9 minus 7 equals to 2. Is map contains 2? Yes, map contains 2. So if map contains 2, what we need to do, we will get this value, we will get this 0 and put it in this array, our result array. Okay, we will get it, and the next thing will be we will get the index of that target minus nums of I. We need to get this index as well. Okay, we need to get this first value index and second value index. We need to get both the index, so we will put these index in this array, and we will come out of this loop. Okay, and we will return the array. So this is how it will work. Let's see with another example. Suppose 2 3 4. Okay, 2 comma 3 comma 4. Now it is 3 to 4. Okay, sorry, 3 to 4, and our target is 6. How will be checking? We are running the loop, and I will remove this thing. This is not of our use. So currently what we will do, we will put 3 comma 0 as a key value pair in the map. Okay, now what we will be checking, we will be checking is 6 minus 3, is another 3 present in this map? Yeah, it is present, but we need to take care of one more thing, like both values will not be the same thing. Okay, both are not same. Okay, 3 to 4, target is 6. Yeah. Okay, so it will come go inside. No, it will not go inside this. Okay, because we put this 3 comma 0. Now I is 1. Okay, yeah, so 3 comma 0 we put in the map. Now we will check, like 6 minus 2, is it present in the map? 6 minus 2 will be 4. Is it present in the map? No, it is not present in the, our key value pair be 2 comma 1. This is our key value pair. Now we will check for 4. Is 4 present in the map? No, 4 is not present in the map. What we will check? Sorry, not 4. We will check for 4. Yeah. So 6 minus 4, is 2 present in the map? Yes, 2 is present in the map. Then we will get this index 1, and we will get the index of 4 as well. And we will put in our result array, and we will store both the things, and we will return that array. I hope this is clear how we are checking, why we are checking this target minus nums of I. Okay, I already discussed it. Let's see this solution and try to, yeah, let's use this solution and try to submit it. Okay, because there are three approaches, so that's why I already uh, did- completed these solutions. Let's submit this. I wanted to discuss couple more approach, but yeah, no, at least these three approaches fine. And if you are, if someone is talking about not to use space complexity, you can use sorting approach or two pointer approach. If someone is talking about better time complexity, then you can use this approach. Okay, I hope this is fine with you guys. Let's see, let's run this code. Okay, it got run. Let's submit this. Okay, yeah, you can see the runtime is 6 ms and memory use is 45.8 ms. And what will be the time complexity of this solution? As we are using hash map, so the time complexity of this solution is, because in hash map the values are O of all the put and get will be O of 1 and O of 1. Okay, so the time complexity, so the time complexity is very less of this solution, so we can use this. Okay, thank you for your time.